Problem 60, parts A and B. The horizontal distance that a projectile will travel in the air is given by this equation, where v is the initial velocity of the projectile, theta is the angle of elevation, and g is the acceleration due to gravity. We have the equation. Let's just go ahead and plug in the equation. Well, first let's find our values. So our value for velocity in part A is 34.8. So we're going to enter 34.8. Sorry, you're going to do two open parentheses because this is on the top. And you want to keep this squared with your number. So 34.8, close parentheses squared. Sine, you don't have to do a multiplication sign because the calculator automatically understands when sine and this is together, it automatically means multiplication. So you're going to have sine. We don't have a theta yet. We're trying to find theta, so we're going to find 2x because we don't have a theta symbol. Divided by gravity, which is 9.8 meters per second squared. Our angle of elevation theta should you direct the throw so the ball travels a distance of 107 meters. We want it to travel 107 meters. So 107 meters would be this, is where we would plug it in. So we're going to put it at y2 to find where they intersect, because that should tell us the angle of elevation. So we're going to go to trace. We're going to take a look at the graph. Wow, the graph's a little off. We may have to adjust the window. So since we essentially can't throw backwards, let's go to our window and make the minimum 0. The maximum we will make 90 degrees, which is pi over 2 in radians, because you aren't going to throw something straight forward. It's just not going to go very
straight upwards.
Straight upwards. So you're going to hit graph, you're going to see that it's not going to fit again. Zoom, fit. You're just going to go straight up and go to the last option. And this gives you the graph of your first equation. The straight line is the graph of your second equation. So you're going to do a second calc. You're going to calculate the intersection between curve A and B. And you're going to go to the nearest guess. That's about close enough. And our first answer for A is 0.523. 0.523 degrees. And then you're going to come over here. Second, calculate again. Intersect first curve, second curve. You're going to guess closer to this curve. And your second answer is 1.047. 1.047. Put that in your curly braces and you're done with part A. B, determine the maximum distance that you can throw the ball. Well, since our y-axis is how far we can throw the ball, why don't we just calculate to find the maximum of this curve. So you're going to want to calculate the left bound, which is the leftmost side of the maximum. So that's good enough. Your right bound is the right side, so you're going to go all the way to the other side. And then you do the guess as close as you can to the top, an approximate value. And your maximum, you're going to look at the y value, is 123.57, and you're going to round due to the 5 to a 6 meters. And problem, there's your answer for part B.